Okay, yeah, so welcome back to Cloud Computing and Big Data, the prologue, unofficial start, if you want, to the lecture part 2. Now that I talked to you on the 10,000 feet perspective, the idea is to think a little bit more deeper what each of the different lectures entail in terms of topics, course materials, right? So this would be something where you can then see lecture by lecture how the course builds on each other, how they're interconnected. Sometimes there are lots of repetitions, but that should also mean these course parts are basically very much intertwined partly. So in the lecture one, we really take another introduction lecture, if you want, from another perspective. We really look on the evolution, where cloud computing comes from. We look also how that has to do then with the evolution of the internet, so that suddenly public people can access the internet and suddenly can have lots of services used, which was basically initially not the idea. If you think about it, it was much more researcher business, starting also with grid computing at CERN and so on, but used for high energy physics, for engineering and so on, and suddenly became cloud computing. So this was quite an evolution in the last 20 years, coming to the really cutting edge that we see today. Then there are lots of terminologies we have to clarify at the beginning of the course. Distributed computing, GPU, centralized computing, where's the difference, and so on. And also think about lots of these technologies that are fueling these servers today. We had good questions in the break already about authorization, authentication, how do you place the different services, what about billing services combined with other services, how to build your own product solution. So all of these parts will be also clarified a little bit there, but there will be also subsequent lectures and talking about individual aspects of this. And then, of course, we switch a little bit the perspective from computing away also to data. So how basically this big data element of the course is catered by these elements from cloud computing. And there's one interesting paradigm that you get, so sometimes can contrast HPC to, where you basically in HPC bring the data to the machines. So you transfer them with big data and with some of the cloud computing accumulating lots of data like Facebook or other social media, that would be not anymore possible. So you have a sort of data to compute versus compute to data paradigm we will talk about. And finally, also that big data is not just volume, right? It's also veracity, sometimes even velocity. So 1 gigabyte is not a problem, but 1 gigabyte per second might become quickly a problem for storage solutions. So this is something what also is entitled in the 7 V's of big data we talk about. Having clarified these fundamentals, and then breaking off the conceptual paths a little bit so that you are early ready for your assignment, we teach some machine learning models in clouds. It will really give you some foundations, how we perceive machine learning, what to do in terms of, let's say, simple learning models, really. So no cutting edge deep learning yet, but still some essence of supervised learning, unsupervised learning, linear learning models we start with to understand a little bit the machine learning, let's say from the ground on, that you can then actually easily transfer into some cloud solutions and services. This will be then also the time where we start roughly with assignment 1, and is actually quite complementary to the lecture 3 on Apache Spark. So Apache Spark is also a very popular cloud technology. You will see that in almost all cloud providers today provided. They have different names. Some call it HD Insight, where the Apache Spark resides. And we basically use a resource group of this, where all of your groups can then access essentially this Apache Spark instances and launch some machine learning in the cloud. That will be one part of the assignment. And of course, there will be some practical lectures showing you a little bit how you actually do this, right? So this lectures that you see here is a fundamental backbone, but every now and then I will also provide some practical lectures, like practical lecture 3.1, for instance. Some of you have already seen that when you go to YouTube, you see there's a practical lecture element sometimes to it, especially there where the assignments are. So Apache Spark is a quite powerful technology, has a base, has different parts for, let's say, supporting different applications. We do a little bit an emphasis on machine learning, but we will also come a little bit back to the graph then when we talk about social networks and so on. I left out a little bit the SQL and streaming compared to the many years before, because now deep learning and machine learning is getting such an important topic that there are just more and more topics like hyperparameter optimization or AutoML techniques we have to talk about today to do a useful job in machine learning. Then we talk a little bit back to really conceptual aspects. I already talked with one in the break about it. So basically how to create your own data center will be a bit part of this. So what are essential elements, just like a, basically double floor that many maybe doesn't see really, where all the cables are and things like that. But also how to basically think about different ways like green computing, how you fuel the whole machinery, right? Usually this takes a lot of energy, a data center today. So hence also we see here some responsible compute and Borealis data centers in Iceland that fuel that, for instance, a lot with hydropower, which is sort of green energy, while my center in Jülich, for instance, has a very, very big coal plant next to it, right? So you can imagine that data centers have very different facets on the green footprint. That's something we have to talk about on the data center operations, but also then how you come from a little GPU to basically racks, and then from racks to really big data center in terms of scalability. So there are different topics really that have also many practical elements from our friends from the different data centers, and we will talk about it. One is also the service level agreements, the pay-as-you-go and pay-as-you-demand service in terms of charging. Then a little bit back to conceptual, because MapReduce has been quite a long paradigm standing in cloud operations for quite a while now, as I also alluding to, and you see that a little bit here on the bottom right, that essentially you see here again the divide and conquer idea of computer science 101, right? So let's say you have a bunch of documents, you want to analyze them, which of those documents are for sports, what is politics, whatever, you want to categorize them into different categories. That is independent from each other, right? You can actually give that out in the course. Everybody from you, it's actually 10 documents, look at this. And then afterwards you say me, well, this was not about politics, that was about sports, it was about this. So we talk about this of being embarrassingly parallel, or let's say some others call it nicely parallel, which is one of the most contrasts perhaps to basically HPC. HPC does a lot of communication all the time, like weather forecast, the physical variables from time step to time step in each of the different quadrants needs to be communicated, right? That's why also some of the cloud computing applications would be infeasible, like for instance, weather forecast. To do so, that would be much more costly in the cloud than using a HPC premise. What is also happening for our weather forecasts, right? In Iceland, the Met Office is, for instance, a Danish HPC system that takes care of it. We don't ship that off to the cloud. But for many application problems, you will see what I also will motivate is this MapReduce computing paradigm, which reflects nicely this divide and conquer. So you map it to the problem, then you have a, let's say, a secret hidden step here that I call sort, shuffle, group, and then reduce. So I will teach you a little bit that this actually MapReduce is sort of a helper in thinking it much more about map, sort, shuffle, group, reduce, right? To basically then group problems by keys, where you then have a nicer idea of combining the results. And we will talk about this. So all of these topics, of course, are loaded. So don't worry if you don't understand them completely now in the prologue. As I said, it's sort of an unofficial start of the course so that you understand the context of the course and what we do in the different chapters. Then the second assignment is really interesting to see where, of course, we will sometimes use CPUs versus GPUs. We will see a little bit where the benefits are then of cloud solutions. That's why we do a small, let's say, course of deep learning. Also because it's really driven by big data, we will make the case, right? So again, here, you don't have to be deep learning experts. Many of the scripts will be provided to you. Of course, still we do the general understanding and some practical lectures to get going with the assignment. And this would be also something where you get some learning experience and what you can hopefully use quite nicely together with other parts of the courses, like from Stain, for instance, that teaches more the deep down details. Then, of course, some applications in clouds. As I said, you see here, remote sensing, for instance, will be one part which we use, but also other application areas which we can use in clouds. Then, as I said earlier, the deep learning is not fueled just by different hidden layers that you put in and add and add and add. Instead, basically, deep learning is fueled by different types of models, right? You see that a little bit here, the RNNs, the recurrent neural network structures, which are nowadays LSTMs, GRUs, gated recurrent units, up to transformers and autoencoders. So their model is basically driven not only by the deepness, but much more about the style and technique which are inherent in every different model. And the same is actually true for large language models, which is now a research project where just one of my PhDs here, Matthias, will also talk a little bit about in the course later down the road. But all of them combined, and that's why it's relevant so much for this course, have these two entities. They need a lot of computing to be successful. And secondly, they require lots of big data to work, right? For instance, learning large language models from Icelandic is quite a challenge because the Icelandic corpora is what we call a low resource language, right? So there's not just so much text about it. So learning to make large language models fly and Google Translate sort of services is not so straightforward like in English, whereas it's a rich resource language. And these things we will also talk a little bit when we have invited lectures in this deep learning, and why large language models also need a lot of cloud computing power to work. Now more back conceptually, thinking now about we have done around or basically you're busy with the second assignment. We will talk about some conceptual topics which are good to understand. Sometimes I have to say already, these are not really clear boundaries. Over the last 10 years, we see them more and more diverging in each other. So one, of course, very famous one is infrastructure as a service, where you sort of think just virtual machines, hardware provisioning, the bare metal basically that you can use and do whatever you want. There's not much more service around it, right? You can install your own operating systems, you can do your virtualization instance with VMware or others. But today you see still lots of good services coming around. We will do basically examples from AWS, where you see infrastructure as a cloud is quite good supported and has interesting features. So we will see the elasticity, for instance, right? So many companies, for instance, have quite a normal profile, but suddenly, let's say if there's some financial report to come, then they have to compute a lot. So they burst out at 1 month, right? Could be a specific tax period, whatever. And to have that on your own computing premises would be very bad. So you have lots of unused resources, and only for 1 month you need this powerful computing. So the cloud was basically a perfect solution for this. You can basically expand the needs or shrink the needs back. And we will talk about this a lot. What is then the key element in this infrastructure resource provisioning? And why it's much more, let's say, cost-effective to do so instead of creating your SME and create your own cluster down in the cellar, right? So this will be an important part of this lecture, justifying what is the infrastructure in this case. And of course, the same goes for storage and interesting types of storage we talk in later, because they also are related a little bit to platform as a service. So platform as a service changes the perspective a little bit. Let's say you're an application developer that needs different, I call it sometimes Lego bricks, to have your own app created, right? You don't want to do this from scratch. So you use something which is already existing, like the Google Cloud Platform. It gives you everything to create your own app. We will have also some application examples. For instance, several don't know that Angry Birds was a completely failure at the beginning, right? So, but then over the years, they used more and more these cloud devices and scaled. And now I think who does not know Angry Birds? Okay, so I think everybody knows Angry Birds are very successful. They actually started with a soccer app, which also completely failed. So you see the success of these companies is also partly derived of using cloud solutions like that, because they're also able to scale with the number of users. And we will make the case for it for the Angry Birds users now, for instance, and for many other devices like Philips, you maybe know with this Lightning and so on, where you can play around. So everything has a kind of nice connection in a way, how you use these different Lego bricks for completely different types of software, but they are reusable, like billing platform parts or actually bucket storages that are available. And you combine them differently. Of course, nowadays come also some platform services of AI that you can combine with them. For instance, natural language processing has lots of machine translation services to different languages and sort of things. But yeah, bear with me, we will talk about this when we have the platform as a service character. Now, the software as a service in a way, and again, take the message that infrastructure as a service, platform as a service, and software as a service are relatively close to combined, and it is a sort of a little bit artificial cut, but still it gives you an understanding of the meaning of the usages. For instance, I believe that almost all of you have used software as a service right now, even if you don't believe it. I guess no matter what you use, Google Docs or some platforms which are in your country and so on, chances are they are fueled by software as a service, SharePoint, whatever, Amazon S3 storages behind. Gradescope, for instance, I don't know if you know this service, it uses Amazon S3 services behind the scene. You don't know that, but basically you just engage in Gradescope. So long story short, that will be a lecture about lots of applications perspectives where lots of money is made today. For instance, one of the most is the CRM market we will look into, customer relationship management with Zoho. But there are many others we will look to why this is basically fueled with cloud computing today and how it again nicely scales out with different solutions. With this, we also talk about the cost models, right? The more you go up the stack, it sounds good. Everything is provided. You don't have to redevelop a billing service with swiping credit cards. You don't have to redevelop the scalability in, out, etc. But more and more, this comes with a cost. The higher you go on the software as a service level or platform as a service level, you have to pay for these solutions, right? To be available, to be running. Like in MS Azure, for instance, when you want to have HD Insight running with Apache Spark, just as an example, this costs you Apache Spark itself. It will cost you storage resources in the cloud. It will cost you computing cloud services. And as Apache Spark is very memory driven, that's where it's got most of benefit from. We will talk about this. You have to also have CPUs with lots of memories. And this is a costly factor. So hence between these is lots of costs we have to also reveal. Right. And with this, of course, an SME needs to incorporate this. Industry needs to incorporate this in the pricing schemes. Otherwise, they run quickly out of funds. It's also an important part to realize. Today, I would say everything has been developed. We almost don't need to develop. We just have to put it together. But this comes for a price in the cloud. And this is an important element, especially if you do a new company. Then thinking about the last part, so the last assignment really, which is more about not really machine learning, but data mining, big data analytics, where we have a small set of problems you have to analyze in the cloud out of this regime, where again, big data analytics is a little bit derived from the analysis in a way of using more technology, of using more correlations, as they call, rather than having really a long data analysis. And we will talk about this in this particular course. Then also the cloud data mining offers you lots of standard algorithms that are often used, for instance, in shopping data analysis. This is here an example which is very famous. Who has heard from diapers and beer are always bought together? No? Okay, no one. Interesting. Well, that's something then we have a very interesting course to talk about. This is quite an interesting element, a sort of pattern that you can also see. Here the idea is basically that diapers and beer, I take that in front, is the reason that usually when this comes out of the UK and they always go to the pub, right? So out, they never take beer at home. So, but when you are having kids, diapers, the situation changed fundamentally. That's why everybody with diapers would buy beer at home. So there are certain patterns that we can unlock. It's not so powerful than being, let's say, a machine learning model that we did before, but still many of the data analysis, for instance, in big data today, can be derived with algorithms like this FP growth, a priori, and so on, these data mining algorithms. And of course, there are cloud services that offer this technology, where we'll have also a look in. Then when we think more about how this is all scaling, this is an important factor if you think about different users, but also different versions of your applications in the cloud computing area. We have lots of tools like Docker containers. I know it's maybe other courses teaching that, Docker Aptainer, something like this. Okay, yeah, Docker files, where you then basically can configure your applications containerized, and with this also quite scalable in different solutions. And for us, important part will be also portable. So once you have everything in a Docker container, chances are you can take it much more simpler from Amazon and put it to Microsoft, right? When you use, for instance, AWS SageMaker, a machine learning tool from Amazon, this can be not just going to Microsoft quickly, right? Hence, there will be more and more stories also that you kind of have a vendor lock of these different cloud providers, right? The more you go up the stack to software as a service, like SageMaker is a very good example, very brilliant tool, lots of payments, but you basically are stuck to Amazon at that point in time. So Docker and many derived Kubernetes, kubelets, Mesos, we will talk about this. It is more a kind of how you deploy now cloud services at scale, right? Because you have to do this for many, many different users on a daily basis to many people in a secure fashion. We will talk about a lot of Docker. Aptena is a solution which is a bit more for the public. It was called Singularity. All our HPC systems, for instance, have Singularity, or nowadays Aptena. We would never use Docker because it's Java, and Java has nothing to do with HPC. But that's why the concepts are still portable, so that you can take a Docker container and massage it a bit, and it will run on Aptena, which is also quite nice. So it's an interesting solution you get here of really shifting your company, let's say, application logic between different cloud providers. And that's also an important part. Then, as I said, a new part, usually we went to streaming at that point in time, so big data streaming. But as our big data storages got more and more, let's say, bigger with exabytes and so on, and the relevance of machine learning gets dramatic, right? So I think, look at all the jobs that are out there. I think many of them are now fueled by AI. I thought this is a much more interesting topic, and we ourselves have lots of good examples out of this, showing that we can really improve deep learning models, that we can improve normal machine learning models with these different techniques, right? For them, some of them are even at CERN, so very prominent. And there's different services we will talk about. We will talk the basics, what is HPO, what we mean by this, but also then what are the techniques, what you use in the cloud. Like, for instance, again, Amazon SageMaker was the idea I told you. But there are also open source versions of it, like Autogluon, right? That you can basically put in your Docker container right now, nicely Python, and then it will work and better your model. So this is something that basically needs to be tweaked much more, because it also saves a lot of time of researchers and engineers and people doing ML modeling. But usually this is a topic that is not taught in machine learning topics, right? It's much more practical emphasis. And of course, you can imagine why it's in the cloud course. It needs tremendous amount of computing power. But we have it unlimited, right? So it's not our problem. We have this. It's not a problem today. Then, as I said also in the break, was in one of the discussions, how to create your own cloud, right, was the idea. And then we come to OpenStack. So OpenStack is something where we switch the perspective a little bit, where we don't say there's Amazon already, MS Azure, Google Cloud, Rescale, and so on. We just say your boss comes into your office and says, well, you heard cloud computing, I want my own cloud, right, in-house. And then you say, well, okay, no problem, I have OpenStack. What do you need? And OpenStack is another piece of Lego bricks, which are not like the platform as a service idea completely, but sort of derived. So you have implemented almost everything you need to create your own AWS at home, if you want. Of course, a little bit not so much on steroids, and it needs to be still fueled by real hardware, right? You need really infrastructure. But everything around that you have there for scaling the computing, for scaling the billing, for scaling the storage, for whatever you want to do in the cloud is basically already existing as OpenStack components. So some call it the cloud operating system. And we will talk about this, how we create our own ones. And you will see many different companies today actually have solutions built on OpenStack today. Then as the last part, because it's also quite popular, but comes to a different emphasis of the course, where we have to potter off to graph databases, graph neural networks, huge topics, right? We can't teach that so easily just in one, let's say, lecture, but I think it's still an interesting, relevant scope for you at the end of the course to see where also much of the community trends going, especially, of course, today, as you see the social networking, social media. If you look on the data structures inherently, it's not at all like an SQL database, right? Name, everybody has an address, everybody has a name, everybody has a phone number, the traditional way of storing data and so on. It's much more interconnected, it's linked, some people have their more information. This is a little bit alluding to this interesting block here. That's how data looks like today, especially in social networks. They're basically bound around interesting events. So how we deal with this? Chances are that graph databases and graph neural networks are much more powerful in this area. And we do also some examples why Facebook is relying on some of those. But of course, in the end, someone like Facebook has also many different databases to combine. We will talk about this, about indexing versus, I like, and this is something what everybody sees the moment you click and not 10 minutes later. So that would be an interesting ending of the course. At the end, which is sort of the unofficial ending, then we will just have an informal lecture again, where we talk about job description, where I basically would like to take you again to Glassdoor and other job opportunities which are out there. And then we compare a little bit the buzzwords you learn in the course and see that they all appear in one way or another in some of the job descriptions worldwide, in Europe, and some of them even in Iceland. So it takes another perspective of the course, also the things that maybe matter still in 10 years, like, map, reduce, divide and conquer ideas and so on, which are more paradigms than rather concrete cloud solutions in the course. Good. And then I think I will just give you a little bit a sneak preview what now deep learning is. For this, I stop the recording again.